So question next. Calculate the wave number, wavelength and frequency of the first line of Lyman series. Okay, here they have given you Lyman series. So you have to think about Lyman series. And they have given first line. And whatever you have to find is wave number, wavelength and frequency. So with the question we can think that they have given N1, N2, right? And for the Lyman series, N1 is 1 and N2 is 2. Now they have told us to find wave number, right? We have to get the formula for wave number. We have already derived it, right? So wave number is given by R 1 by N1 square minus 1 by N2 square. So further substituting the values 1 by 1 minus 1 by 4. So we arrive as 3R by 4, and substituting the values we will get some 0.287 into 10 raised to 7, or you can write it as 822.7 into 10 raised to 4 per meter. So you have wave number here, right? Next is they have to told you about the wavelength, right? They have told you to find wavelength. You can write this as mu bar is nothing but 1 by lambda. So we need lambda, so 1 by mu bar. Substituting lambda is equal to 1 by 822.7 into 10 raised to 4. We will get some lambda is equal to, so you'll get 1.215 into 10 raised to minus 7. So you should be careful while doing this, or you can write this as 1215 angstrom. So be careful about this. Next they have told wavelength, and next is the frequency. I'll continue here itself. Frequency, can you relate frequency with whatever we have already solved? That is, frequency is known as mu and it is C by lambda, right? We have lambda there. We know C is nothing but 3 into 10 raised to 8, and lambda is 1215 into 10 raised to minus 10 angstrom, right? Which is nothing but mu by, frequency mu is equal to 24.6 10 raised to 14. Actually you will get in 18 range. Actually this answer will be something 0.00246 into 10 raised to 18, and after pointing here you will get 10 raised to 14 hertz, or you can stop here itself, no problem, if you have the problem with raising the power. The next problem is calculate the orbital velocity and frequency of revolution of electron in the second orbit of hydrogen atom if the radius of first orbit is 0.53 angstrom. Calculate the orbital velocity. It is nothing but velocity. Frequency of revolution. Here new term has arrived in revolution. How many times electron have revolved around the nucleus in the second orbit of hydrogen atom if the radius of first orbit is 0.53 angstrom. So what is given? So R1 or not. I think you have seen in the derivation when for the hydrogen atom we have taken it has A naught R1. R1 is nothing but A naught. I think everyone remembers it if they have seen the notes as well as the videos. So you can write this as R0 or R1. There is no problem. I will represent it as R0, 0.53 angstrom. That is given, and also N is given. N is 2, right? We have to find V and frequency of revolution. Before going further, we have to know what's the relation for the period of revolution. Period of revolution is given by T is equal to 2 pi R by V. This is 2 pi R is nothing but the circumference, right? And V is the velocity. But they have asked us to find frequency of revolution, right? How you can write frequency of revolution? Mu is nothing but V by 2 pi R. Why this is? Because 1 by T, right? frequency of revolution, period of revolution. Frequency is given by 1 by t. Therefore, you can write frequency of revolution as mu is equal to v by 2 pi r. So we have to find Vn, right? Vn is nothing but E square 2 nh epsilon naught. V1 we have to get V1 or V2? V2, sorry. E square is given by 1.6 into 10 raised to minus 19 the whole square, divide by 2 into 2, this n is 2, 6.63 into 10 raised to minus 34 into epsilon naught 8.85 into 10 raised to minus 12. So what we will get is V2 is equal to 1.09 into 10 raised to 6 meter per second. So velocity is generated by the unit meter per second. I think you know very well about that. Now we have to find a frequency. Okay, what is a relation between frequency of revolution? That is nothing but V by, that is Vn 2 pi r n. We know Vn, that is V2, we have got some 1.09 into 10 raised to 6 meter per second, right? But we don't know R2. How we can find R2? So there is a relation. As we know, R2 is nothing but A naught n square. We have seen in the derivation. We know A1, right? A naught is nothing but R1. So here I have taken R naught, sorry, it must be R1. This is R1, or you can write it as A naught also. So if you substitute that value here, A naught is 0.53 angstrom and n is nothing but 2 square. So R2 will get as 2.12 angstrom, right? Now substituting these values here, we get mu, that is a frequency of revolution, mu, V2 by 2 pi R2, right? We have V2, R2 and we know the values of 2 pi. So substituting values of these things, whatever we have, we get into R2, 2.12 angstrom, 10 raised to minus 10, right? Now you can write this as 0.0818 into 10 raised to 16 hertz, or you can also write it as 8.18 into 10 raised to 14 hertz. So we have arrived at the expression for frequency of revolution and also orbital velocity for the second orbit. So in this way you can solve this problem. Next problem is, using Bohr model, calculate the orbital period of an hydrogen atom in n is equal to 1, 2, 3 levels and calculate the velocity for those levels. So we have to find t as well as velocity v, both for n is equal to 1, n is equal to 2, n is equal to 3. Here I will show one problem, that is n is equal to 1. Then you have to clear your doubts by solving the other two, n is equal to 2 as well as n is equal to 3. Okay students, so period of revolution is given as 2 pi rn vn, and velocity is given as vn is to nh epsilon naught, right? We have this relation. So already I have told, before starting the problem you have to get a list of formulas. Okay, now just substituting value of n is equal to 1 in both the cases, you will get, and n is equal to 2 in both the cases, n is equal to 3 in both the cases. I will be solving only one and the other two I will leave to you. So t1, right, let us take this tn. So 2 pi r1 by v1. Before getting this we have to find v1, otherwise nothing is there to substitute there, right? So v1 is nothing but 1.6 into 10 raised to minus 19 the whole square, 2 into 1 into 6.63 into 10 raised to minus 34, 8.85 into 10 raised to minus 12. If you substitute the values for the above, you will get v1 as 0.0218 into 10 raised to 8 meter per second, or you can write this as 2.18 into 10 raised to 6 meter per second. Use your calculator and do it. Next, you got V1. Substitute V1 in here, you'll get T1. So T1 is nothing but 2 into 3.14 into R1. What is R1? 0.53 into 10 raised to minus 10, right? A0. R1 is nothing but A0. We have derived the expression you have seen there, okay? Then V1. V1 is nothing but 2.18 into 10 raised to 6. So T1 we will get as 1.526 into 10 raised to minus 16 seconds. So in this way you can solve. For n is equal to 2 and n is equal to 3, how you will find R2 and R3? Check it. See, for R2 is nothing but A0 n square. You can substitute A0 as R1. It is nothing but R1, right? Then for R3 you can substitute A0 and n square. Same thing. You will get R1, R2 and R3. So students, you can find R2 has A0 n square. So you can find R2 has A0 n square. Here n values only varies, A0 remains the same. For 3 it will be 3 square, n is equal to 2, it will be 2 square. So you will get R2 and R3 in this way for other two n values. So total next question is total energy of electron in the first excited state of hydrogen atom is minus 3.4 electron volt. What is the kinetic energy of electron in this state? What is the potential energy of the atom in the electronic state, or the electron in the next state, right? So how we can find this? So given is total energy is minus 3.4 electron volt, right? Total energy is nothing but kinetic energy plus potential energy. We know potential energy is nothing but minus 2 times the kinetic energy. Why? We have the relation, right, for kinetic energy and potential energy. If you go through the derivation you can understand. If not, you can ask in the online class. I can explain it there. So we can write total energy as kinetic energy minus 2 kinetic energy, 2 times the kinetic energy. That is nothing but total energy is minus kinetic energy, right? So total energy is given as minus 3.4 electron volt of minus kinetic energy. Therefore minus minus cancels, therefore kinetic energy remains as 3.4 electron volt. Now we have to find potential energy. Potential energy we have taken as minus 2 times the kinetic energy, minus 2 into 3.4 electron volt. We will arrive at the answer as minus 6.8 electron volt. Only this much. So go to the derivation first. Get how we got to minus 2 times the kinetic energy. You have to think about it. I'll not feed everything for you. You have to check with the derivation and come to the conclusion. If not, you can ask in the online class. So now next problem. For first orbit, with the first orbit of hydrogen atom, we should calculate radius, kinetic energy, frequency of revolution, velocity, potential energy, Rydberg constant. Everything we have solved already. So I will just give the hint. You have to solve it yourself. So they have asked for the first orbit, that is n is equal to 1, and with keeping n is equal to 1, you have to find radius Rn, Vn, kinetic energy, potential energy, frequency of revolution mu, that is v by 2 pi r or 2 pi r by v, v1 by 2 pi r1 for frequency. And one more question is about to find Rydberg constant R. Rydberg constant R is given as m e power 4 divided by 8 epsilon naught square h cube c. So just substitute the values of these. Here you do not need any of the values. You have directly substitute how much you will get. You look into it. For this you need the values of V1 and R1. So calculate this too. So kinetic energy, you know the expression, substitute, potential energy, substitute. So this much. This is about problems related to atoms. If you have any doubt, clarify in the online class.